So this is going to be an epic Chapter 8 test review. Let's go. Hopefully you did fine on this. I'm going to allow you to skip through it. So if there's problems that you get and you don't need to see the work for, skip it and go to the ones you need to see. Now, right? Be responsible. Make sure that you're prepared for the test on Thursday. Here we go. First, we have to figure out what we're trying to find. We need to read carefully so we don't make any silly, avoidable mistakes. We're finding circumference of the circle, all right? And we are looking to use pi as the approximation, and we're going to round to the nearest tenth. So those are all important parts of the description here. Now, if I don't remember my formula, then I'm going to go find my formula. Here's my formula sheets. Down at the very bottom, we have our formulas for the two-dimensional shapes, and it looks like I have circles and I have my circumference formula. So I'm going to use those circumference formulas. So I'm going to write them down. Circumference equals pi d, or circumference equals 2 pi r. In this case, since we only go from the center to the outside of the circle, we're going to use the radius formula, and I'm going to change this to approximately because I'm using an approximation for pi, and I'm going to plug in the 9 there, and my circumference is approximately 28.26 millimeters, and just regular millimeters because circumference is a length, not an area or a volume, and it says round to the nearest tenth, so that's going to be 28.3, and that's going to be C. All right, I don't need to use this formula because they didn't give me the diameter, they only gave me the radius. Next, all right, excuse me, we're still following these directions up here. Find the circumference, so circumference equals pi times d, or circumference equals 2 pi r. Well, it looks like we have all the way across, so let's not use the radius formula, let's use the circumference formula. We're going to use the approximation 3.14, and that's going to be 4.2, so circumference equals, and that comes to 13.188. But it says round to the nearest tenth, so 13.2, and that's going to be regular old centimeters because it's a circumference, which is a length, which is a one-dimensional measurement. Now we're going into two-dimensional measurements because number 3 says find the area of the circle. So we look at our formula sheet. We see circles, we see area, pi r squared. So now we have area equals pi r squared. We have area equals 3.14. They say to use 3.14 for pi. The radius is 4. We're going to square that. When I put that into my calculator, it comes to 50.24. We round to the nearest tenth, and that comes to 50.2, and that's going to be yards squared because this is a two-dimensional measurement. Area is a two-dimensional measurement. So we are moving on. 4 goes along with the directions for 3, so we're finding area again. Area equals pi r squared. Area equals 3.14 times, oh, don't make this mistake. We know 10's all the way across, so to find halfway across, we just divide it by 2. That's going to be 5 squared. So our area is, when we multiply that, 78.5, and that's going to be feet squared because we have a two-dimensional measurement. All right, now we're going into three-dimensional measurement. How much space is inside this rectangular prism? Well, let's go check it out formula-wise. All right, formula-wise, we're not in two-dimensional shapes anymore. We need to go find prisms. Where are they? There you go, prisms. So we have prisms, and we're doing volume, so we go to the left box here, and it looks like we have volume equals big BH. Or we can see down a rectangular prism, it's already adjusted the big B to be B times H, or we can do the volume equals length times width times height. So let's check that out. Okay, so we can do volume equals capital BH, or for rectangular prisms only, we can use this LWH. When it's a triangular prism, you can't use LWH. You have to use something a little different because the base is different. All right, so big B in this case is a rectangle. So we use different formulas for different shaped bases. Here's my base here that I'm looking at. That's going to be 9 times 4, so that's going to be 36. So big B is 36, and the height is this 2 here. It's going to be 2, so that's going to be 72. And that's a three-dimensional measurement, so we're going to do meters cubed. Or we can do LWH over here, and that's just 9 times 4 times 2, and that comes to 72 meters cubed as well, and that would be C. Okay. We are cruising. All right, now we have a cube that has 5-inch edges, and we're finding the volume. This is the exact same thing as this. It's just written in a little different way. We can use volume equals big BH because a cube is just another type of prism. We can do volume equals LWH, or we can do volume equals the side length cubed. All right, because you'll see as we go through this. So volume equals, what's the area of the base? Big B stands for area of the base. Well, if we draw this out, here's my cube. All right. Here's my cube. Well, it's 5 by 5 by 5. So the base, if we look at this as being the base, we have 5 times 5, and that's 25. So we get 25 for the area of the base times 5 for the height, and that gives us 125. If we do it this way, we get 5 times 5 times 5, because that's the length, width, and height, because all the dimensions of cube are the same, and that comes to 125. Or we can get 5, volume equals side cubed, so 5 to the 3rd power. Since all the dimensions are the same, we just multiply by itself 3 times, and that comes to 125 as well. And all of these should be inches cubed. So we have 125 inches cubed. Boom. Now, still three-dimensional, we're going volume, number 7, and we have to identify the shape because they didn't tell us what it was. This has a single base with triangles going up to an apex. So that is a pyramid. So we're finding the volume of a pyramid. Let's go check our reference sheet out. We're in the prism section here, so we have to find the pyramid section, which is right here, and make sure we go to the left side because that is the volume section. All right, so now we have to use the volume formula. Volume equals 1/3 big BH. Big B being the area of the base. So volume equals 1/3 big BH. We'll solve for big B over here, or we'll calculate big B over here. The base being a rectangle, so we'll use the formula for a rectangle. That's going to be 10 times 10, which is 100. The area of that base is 100, so we have 1/3 times 100. And the H in this case stands for the height of the prism. No, not prism, pyramid, the height of the pyramid. And the height of a pyramid always meets the base of the pyramid, this shape here, at a right angle. All right, so this is our height, which is 8. Now let's multiply those on a calculator, and we get, for that one, number 7 is 266 point, I believe it's 6 repeating, but we're going to cut it off because it rounds to the nearest tenth. And this 6 in the hundredths place tells the 6 in the tenths place to round up. So we get 266.7. It's volume, so it's going to be inches cubed, three-dimensional measurement. So there we have it right there, D. Moving on. Whew. Oh, man, this is tiring, rushing through all this. Okay, we're following those same directions up here for volume. And it's another pyramid. And in this case, we have a different shaped base. All right, see this height here? The height of the pyramid meets that base shape at a right angle. So this is our base shape here. We're going to write down the formula for volume of a pyramid, which is 1/3 BH. If you forget it, just keep that reference sheet handy, okay? We're going to find the area of the base over here. It's a triangle. So the base of this pyramid is a triangle. So we need to do 1/2 base times height for the area of that triangle. Notice, big B here on this problem, because the base was a rectangle, we used B times H. Here, for big B, we're using a different formula because the shape of the base is a triangle. So we're using 1/2 base times height. Now, challenge. This one has tripped people up in the past. Look at this triangle here. It has all three sides labeled with numbers. The lengths of all the three sides are there. So how do we know which one to pick? Which two to pick, actually? Well, we look for that right angle. So there's the right angle. So 9 and 12 are the winners. 9 and 12. There we go. And that's going to give us 54 when we calculate that. And we are going to now plug that in for big B. Volume equals 1/3 times 54 times the height. Now this isn't the height of the base. This is the height of the whole pyramid. And that's that guy there. So that's going to be 16. Now we just have to calculate that. We can use our calculator. And it comes to 288 inches cubed. And, oops, not inches. Sorry about that. That's going to be meters cubed. All right. My hands are like going numb because of how fast I'm writing and how intense I'm being. All right. Now we're on to surface area of each figure. So that's a two-dimensional measurement. We have to find, well, let's go look at our formula sheet. Okay. We're in the pyramid section now. So we don't want that. We want prisms. And we're going over here to the surface area to the right box, to the surface area box. And we have a rectangular prism, so we're going to use that formula there for rectangular prism. Or we could, in fact, use just find the area of all the faces and add them up. That's essentially what the formula does for us. But most of you will like to use the surface area formula, so we'll do that. 2LW plus 2LH plus 2HW. And now one clue on this formula, since there's so many variables, we're just going to label the numbers, the dimensions, with LW and H to keep them straight. All right, 2 times 13 times 9 plus 2 times 13 times 4 plus 2 times 9 times 4. We kind of, each one gets paired up with each of the other ones. And let's see what we got here. When I type that all into my calculator, I get a whopping 410 inches squared. So that is that one right there. All right, make sure you follow order of operations unless you just throw it all in your calculator, and then your calculator will follow order of operations for you. Otherwise, you find that, you find that, you find that, and then you add those three results up. Moving on. Okay, we're still doing surface area, it looks like. And for number 10, we have to find the surface area of this triangular prism. We have a triangular prism. How do I know it's a triangular prism? Because I have two matching triangular bases, and the other lateral faces are rectangles. All right. Even though it's not sitting on those triangular bases, they are matching, congruent, parallel, so that this is a prism. All right, how do we do this? Well, if we look at our formula sheet for prisms and we go to surface area on the right side and then we go down to triangular prism, it says no formula. You have to find the area of each face and add it up. So we're going to find those. I'm going to find the area of the triangles and I'm going to times it by 2 since there's 2 of them. Then I'm going to do each of the rectangular faces, the bottom, the left, and the right. And then once I get all those, I'm going to add them all up. Okay, so let's start with a triangle. Area of a triangle is 1/2 base times height. 1/2. Now, all three sides of the triangle are labeled, so to find the base and the height, we need to look for that right angle. I got it right there, so that's going to be 12 times 16 for that. Area equals, that comes to 96. I'm going to times it by 2 since there's 2 of them. And I get 192. So the area of those two triangles total 192. Now let's go to the bottom here. What are my dimensions there? It's a rectangle, so we're doing base times height. We need to find the two dimensions, and that's going to be 14 and 20. So 20 times 14, and that comes to 280. All right, let's go to a different color here. Let's go with this color, beautiful. And let's go to this one over here, the left side there. Area equals base times height. Area equals, interesting, this side is 12. And again, we're using the 14. Just like we use 14 for this one, we use 14 for this one. Each of these lateral faces, each of these rectangles is going to have that same dimension of 14 because that's the height of the pyramid. All right. So what do we get when we multiply that? We get 224. Nope. Sorry. Looked at the wrong spot. We get 168. And then we have our final face is this one over here. All right, it looks like that's going to be base times height. Area equals, it looks like 16 times 14 in this case. Right, those are the two dimensions of that. And that gives us our 224. And now we're going to add up. We're going to add up all of the areas. Going to add all those up. So 192 plus 280 plus 168 plus 224, and that gives us 864. So 864 feet squared. Remember, surface area is a two-dimensional measurement. 11. Find the total surface area of the pyramid. Surface area. Pyramid. Let's go check our reference sheet. Oh, got to go to the pyramid section. Got to go to the right column. And we have surface area. Ooh, this is a fun formula. Surface area equals the area of the base plus 1/2 the perimeter of the base times the slant height or the lateral height. All right. So surface area equals capital B plus 1/2 PL. I'm going to do B over here and P over here, and then I'll substitute them into the formula. Big B is the area of the base. So let's look at the base of this pyramid. It's a rectangle, so I use BH. I got 10 times 10, which gives me 100. So now I know that big B is 100. I can plug it in. Now I need to know what big P is. And big P is the perimeter of the base. So that is just 10 plus 10 plus 10 plus 10. Or you could do 10 times 4, and that gives us 40. So now we're going to plug in 40 here. And the lateral height is the height of the triangles on the lateral faces. The lateral faces are triangles in this case, and that's going to be 4. When we type all that into our calculator, we get 180. Is this square units or cubic units? It's surface area. That's a two-dimensional measurement, so we get inches squared. So where are we? 180 inches squared. There we have it. We're over halfway there. Hang in there. Skip around to the ones that you had the most trouble with, and make sure you're prepared for our test. 12. All right, we're finding circumference of a circular pond with a radius of 14 meters, and we're using 3.14 for pi. If you don't remember, go back to our formula sheet, find circles. Notice that on the left column here, there's two formulas for circumference, and we're going to use the one that they give us the information for. So since it says radius, there's two circumference formulas. There's pi d, and there's 2 pi r. Well, we're not going to use that one. We're going to use this one because it has an r in it. And they give us the r, or radius. So 3.14 times the radius of 14. And when we type that into our calculator, we get 87.92. And actually, I should put approximately there because I'm not using exactly pi. It says, let's say it round to the nearest tenth. Yes, it does. To the nearest tenth over here. I didn't underline that. So it's 87.9, and it's just meters because circumference is just a length. It's not the area of a flat surface. It's just the length. I know it's a curved length, so it's confusing a little bit, but now it's just a length, so it's just regular units to the first power. What is the area of a circle? Nearest tenth, use 3.14. There we got all the important information. I know this one. It's pi r squared, and I am just going to use it and not refer to my reference sheet. Okay, that got me in trouble in one other video when I forgot the formula for the volume of, or the surface area of a pyramid, but I think I figured this one out. I know this one. All right, I have my radius, and that's going to be 6, so we're going to square that. When we type that in, a lot of times when I type that into the calculator, I like to just type it in as 6 times 6. So I'll type in 3.14 times 6 times 6, because I don't often know where the square button is, and it's just more convenient to write 6 times 6. All right, 13, so that would be 113.04. It says round to the nearest tenth, so it's just going to be 113.0 because we chop it there. 4 tells you to keep the previous place value. So boom, and oh, it's square units because we're doing area.